Welcome back to another video. We're going to do the converse of corresponding angles theorem. This is the one we just did. We're actually going to go through the converse of 3 theorems in this quick video. The first one is that if we have corresponding angles that are congruent between two lines cut by a transversal, we don't know what the lines are. We don't know if they're parallel or not, but they're cut by a transversal. Okay? If we know that angles 1 and 2 are congruent, then what do we know about the lines? Well, then the lines are parallel. This is the then part, and up here is the if part. Okay, if angle 1 is congruent to angle 2, then the lines are parallel. This is our converse of the corresponding angles theorem. Okay, so let's go ahead and write that out in its official statement. Okay, if two lines cut by a transversal have congruent corresponding angles, then the two lines are parallel. Boom. Okay, that's our if-then statement. All right, let's go ahead and write that really quickly. If corresponding angles are congruent, then parallel. That's our converse statement. All right, alternate interior angles. Let's go ahead and think about that. Draw some alternate interior angles here. Boom and boom. Okay. Put some arrows there and cut that with a transversal right there. Alternate interior angles. So let's say this angle and this angle. If these are congruent, angle 1 is congruent to angle 2, then the lines are parallel. Now notice how this goes backwards. The if and the then have been switched. That's what a converse does. If congruent, then parallel. Now, just to make it easier on myself, I'm going to quickly copy this one. Oh, there we go. Duplicate that and just make a quick change here. All right. And rather than corresponding, I'm going to put alternate interior angles. All right, then the two lines are parallel. We just have to make one last change to this. Change CA to alternate interior angles. Boom, we're done. All right, finally, the converse of same side interior angles. This was the one you were expected to prove yourself. So let's go ahead, draw some lines, cut by a transversal, slice. Okay. So we've got those two lines cut by a transversal. If angle 1 and angle 2 add to 180, they are supplementary. Okay, so if sup, then parallel. That's it. If supplementary, then parallel. Just like we did to the last one, we want to go ahead and write it down as well. So I'm just gonna write out a new one this time because it's gonna be a bit different from the other one. But of course, as we get more experience, we can start to shorten it, and that's what I'm gonna do. Okay. If two lines cut by a transversal have a SSIA that are supplementary, then the lines are parallel. Yeah, I didn't shorten that one up that much. Just realized I had to use a supplementary. There you go. Then the lines are parallel. Boom, all done. All right. Look at that. We're almost done with this whole page. We got the triangle sum theorem, parallel lines on a coordinate grid, and perpendicular lines on a coordinate grid to go through last. So with that said, I hope you have learned a lot and you've kind of focused on those supplementary angles, those corresponding angles, and those alternate interior angles, and how they work backwards. Have a good day.